लाईव्ह सुरू झालं. स्क्रीन नंतर घेतो सर. Okay, all of you, the participants, good morning to all. Very first, sorry for inconvenience because at the rural area there is a light issue always we are facing, and even though in COVID situations we are facing, everyone is facing the problems. We should understand that, and that is why we are late for 5 to 10 minutes. Sorry for this inconvenience. We are starting our session today. I request Snail ma'am, please start the today's session. Snail ma'am.
Thank you, Vaibhav sir. A very good morning and warm welcome to everyone. I am Ms. Nehal Mumbaikar, Assistant Professor at Ramrao Adik Institute of Technology of the Department of Computer Engineering, RAIT, DY Patil, deemed to be University. I welcome all our participants and viewers who have joined us through YouTube live to our Day 2 online faculty development program on recent trends in IoT sponsored by AICTE Atal. I feel privileged to extend my warm welcome to our today's speaker, Mr. Amey Tambe, sir, Director SoftTech Data Securities and Director Alka Technologies, who is going to take hands-on session on of IoT and applications in industry, ML and IoT devices. Mr. Amey Tambe, sir, is a consistent performer with a strong record of superior performances, seeking challenges assignment across the industry. As an InfoSec specialist, his qualifications include a degree in computer application, CISSP, CISA designation, and detailed knowledge of security tools, technologies, and best practices. 10 years of experience in the creation and deployment of a solution protecting network, systems, and information assets for diverse companies and organizations. He earned his bachelor and master in computer application from the University of Pune. At institution level, he handled workshops and regular courses, conducted faculty development program and student development program in subject areas of information security, network security, information security management systems over the institutes Savitri Phule, Pune University, Yashwantrao Chavan, Maharashtra Open University, Mumbai University, as well as Dr. Babasaheb Ambedkar Technological University, Lonere. He has also worked with the various organizations and government to handle their corporate and complicated network as well as data security practices such as Indian Air Force, DRDO, Indian Army, and National Investigation Agency. His comprehensive contribution continues with the immense technical certifications such as Certified Information System Security Professional, Certified Information System Auditor, EC Council Certified Ethical Hacker, EC Council Certified Forensic Expert, etc. His technical expertise includes Windows Server products, SAN storage, HP, VMware, EMC Symmetrics, cloud computing products, Cisco and Juniper firewall, load balancer and UTM, IDS or IPS, Red Hat server, Linux or Unix, application security, OpenStack developer, blockchain and crypto, MongoDB, IDM, Amazon, AX system, Bluecoat. He worked as a network security manager in IBM Private Limited since 2007 to 2010, as a senior network security manager in Tata Teleservice Private Limited since 2010 to 2013. We are glad to have you with us, sir. I welcome and invite Mr. Amey Chandrakant Tambe, sir, to start with the session. Over to you, sir.
Thank you very much, ma'am, for my introduction, and my deepest apologies to all the participants as because of the uh, power issue at my place, we got disconnected. Otherwise, we would have started at the time. But never mind. What we can do today is, as the topic is concern, we will be talking about various applications of IoT, Internet of Things. As my introduction is suggesting you that I am an information security guy, right? So, but it is my passion to learn new technologies, and this passion is driving me through with a lot of new opportunities what I can get. So, I'm extending my knowledge, or what we can say, a learning methodologies with the IoT, machine learning, deep learning, deep neural networking, hyper neural networking, blockchain, all these technologies, which is very fascinating. And if you can see that these technologies are very much in demand nowadays. Now, if we can look at this COVID situation, and if we can look at this current scenario of learning, or current scenario of the entire market, everyone is working from home. So, the auxiliaries technologies what were there nowadays, these auxiliary technologies are now a mainstream technologies. Now, for example, like we are having this StreamYard or the live conferences, right? So maybe this live conference is based on the cloud computing, and the cloud which is provided by StreamYard or YouTube, it is taking our live streaming sessions and providing onto various devices. Or when we are say various devices, those devices can be IoT enabled devices. Right now, many of us are already logged on to this meeting through their mobile phones, right? So can we say that mobile phone is IoT device, or can we say that a mobile phone is a computer? What is your opinion on that? Meanwhile, on the session, when I'm going with the session, if you feel that you wanted to ask any question, or wanted to stress down on a particular part, then please feel free to write in your chat, so I can take all the queries and all the questions one by one as I can, right? So, while talking about these IoT devices, or talking about mobile phone, like what do you think that can we say that mobile phone is an IoT device, or can we say that mobile phone is a computer device, or we can say mobile as a computer? We can, yes, we can. What we can do is we can called that device as IoT and as computer, both the things. Because what specifically IoT means, IoT is yes, they have said it well. IoT device, we can call it as a IoT device, because what exactly IoT is, Internet of Things. Means what? Whatever the applications you will be getting, whatever the hardware you will be getting, which can communicate on the network. It is not always like internet, but it can communicate on network. That time, that on particular time, we can say that whatever the device we are having, that is the internet enabled device, the IoT device, we can say. With the IoT, there is a filterized term for IoT now, that is IIoT, which means that industrial internet of thing. With that, we are having a new concept, that concept is not that new, but we are having it called it as BOYD. Means what? Bring your own device. Now when we say bring your own device, it means what? We are having a variety of networks nowadays to cater all these kind of requests of getting your personalized devices on work environment. Like we are having a network which is which we already know that LAN, WAN. With that, nowadays we are having SDN, that is software defined networks. We are having IP based networks. We are having application based network. We are having a particular port or particular service based network. So all these kinds of networks are already there. So when we say the recent trends, now this recent trend is not only talking about IoT. These recent trends, or the IoT, is nowadays a mainstream technology consisting with other auxiliaries or mainstream technologies, because alone IoT devices cannot make your life easy. So if we see that on your mobile as well, you are seeing a pretty good camera nowadays. Let's suppose a high definition camera you are having on your mobile. So when you are taking a selfie, that mobile camera is automatically detecting your face, automatically detecting your facial points, or automatically detecting your what we can say expressions, or we can use that mobile phone as authenticator module as well in some of the application what we can build. So what is that? That is a narrow intelligence which is there in your application. Now we are talking about machine learning. Let me give you a gist of what machine learning, what we observe. It is not like I'm not denying any fact which is there already published on some papers, or there is on the book definitions. I'm not going to challenge it. Whatever the talk I am giving you, that is completely based on the observations what we are seeing in this current industry. So when we are saying the machine learning, so what exactly machine learning is? Machine learning, it means that training your machine to do particular task. Now your machine is like a baby the baby which is going to learn something, right? So if we are talking about a baby which is of a hardly 6 or a 7 month old, that time that baby is trying to observe the various things which are there on that environment, which is there on the house, or whenever you take your baby out, or for a ride or something. That time if you observe that baby's eyes are looking everywhere, learning new things. Similarly your machine is like that. Machine is learning new things, whatever the data you will be putting into it. So we can say that machine is sometime it is a dump application as well. Like in Marathi we always called it sankamya, means whatever task you will be providing to it, that only task that machine is going to do, or depending upon the training data what you are training on, or you are training that machine to learn something. If you are feeding that data with the wrong statements or with the wrong inputs, then definitely machine is going to learn that wrong statements only. So if you are desiring that machine should give you a particular answer, or machine should give you a particular prediction in a terms of AI, or in a terms of what we can say intelligence kind of thing, that time you need to have your data set appropriately crafted, or appropriately handled with all the prerequisites of data. So if we are taking machine learning approach with IoT, then what kind of applications you can build on? So before moving on that, we need to understand how exactly the IoT ecosystem is working. So let me switch to my presentation. uh, is my presentation visible? Is my voice is okay? Any disturbance in that? It is good, it is visible. Yes. Yeah. Okay. Great.
Yeah.
So, what will be the today's agenda? We will be talking about what exactly Internet of Things is. Then we will be talking about why do we need this Internet of Thing. Then definitely the benefits and IoT features is, I guess it is already covered in your last sessions, yesterday's session. So just we will be looking at that. So just we talked about these mobile phones. Now this, if we talk about the mobile phone and the facial recognition ability of it, but with the mobile phones, if you closely look at that gadget, I'll not preferred word using device, I'll use the word gadget. So in that gadget there are several sensors are attached, like sensor to detect your voice, sensor to present you something, sensors to detect the gravitational force, like we talked it as G points, that where that gyroscope is going to work. It is going to positionate you, and if you wanted to see that application, the perfect example of gyroscope, you can open a compass in your mobile phone, and that compass is utilizing that gyroscope which is there, a very tiny sensor which is there on your mobile, and that tiny sensor is capturing all the data on it. Then we are having GPS sensor on it, or we can say the modules, basically. So the GPS module will be there, Wi-Fi module is there, Bluetooth module is there. So we are having pretty various things which are combined in that small device, and that entire combination we are talking as a device. So what exactly all these sensors and modules are? These all are the collaborators for a particular work or a particular actions what that user is going to perform, or what that particular action needs to be performed by a particular user. So in our case, we can have a voice call facility, we can have a video call, we can have various applications which are running on. Even if you can closely look at the Snapchat application, I believe that on Snapchat also they are using some kind of a machine learning approach or an intelligence approach to capture your images with a lot of filters on it. So if you can see on the filters, you can make funny faces on it, you can detect on it. So altogether, if we can look at, is this can be a machine learning. I'm not saying that it is a machine learning, but yes, it can be a machine learning for accurate detection or for accurate what we can say prediction of the different things what we can see. So this particular device which is having all these smart equipments on it, we are calling it as a smartphone, because nowadays phone is not only for calling and receiving the call or having a text messages exchange. It is for almost 90% phones are used for gameplay or taking a selfies. But if we can look at the very professional use of it, like I'm using it, my WhatsApp application, the 90% chats are professional chats than the regular family chats. But see, it is totally depending upon that user, how that user is utilizing your services. So whatever the service you intended to use on the network, and it is packed in a hardware, that hardware we can call it as an Internet of Thing. So the BYOD concept came into Internet of Thing, saying that any device which can contribute on that network to share information, it can be a part of that network and can be called as a IoT device. That's why BID is now nowadays more what we can say popular than the other networks offerings which are there. So if we consider with the smart city projects what government is undertaking with the various cities, if you can see that the smart city is not only talking about the smart lighting what we can see on the street, it is talking about the different areas of sanitization, right? Because of this COVID situation, you can have multiple autonomous drone which are going on the street and sanitizing those streets. Or you can have intelligent light system where you can utilize hydropower electricity or whatever the electricity you are getting through. If we talk about Maharashtra, the MACB or your state electricity board, with that you can utilize the solar power consumption, and you can maintain the balance between it. Or you can control the power distribution through a single application, and those power distribution is handled by a device which is fitted on the power distribution circuit. Or I believe that later on you will be having IoT with the electric grid circuits or electronical grids. So how exactly this IoT is transforming the traditional power distribution with the optimum level of power distribution? That example you can see on your home automation systems, like uh, and on a home automation system, if we talk about, it is not again regard with the light, like somebody comes into your room, automatically light switched on, and when it gone or nobody is there in the room, then light will off, or your particular fan or whatever the appliance is controlled over there. But if you can see that home automation is not only consist with these fancy things, it can consist with your security appliances as well, your door locks, your car locks, or garage locks, or some kind of security parameters what you can set, the biometric or sensor based, or even the DNA based locking systems are coming up. So all these kind of stuff, when we are creating it with the collaborative platform, we can talk it as a Internet of Thing, right? So By definition, what we can say that connecting everyday things embedded with electronics and software and sensors, and I'll add into and modules to the internet, enabling them to collect and exchange data. Now here we need to focus on these blue things, like everyday things, like just we talked about your light, fridge, appliances, even your vehicle. Nowadays vehicles are coming with remote control, vehicles are coming with the various controls which we can get on the your mobile phone. Honda have just launched its own a mobile application which talks about the diagnostics data about your car. You can get any fault related notification on your mobile, directly from your car. It is not from your internet, directly from your car. So maybe even for better security, that car CPU is directly synced with your mobile. It is not sending data onto a cloud. That facility is there, but still you can restrict that, or the manufacturers are collecting that data. Even if you can see that if there are solar panels installed on your buildings or your society or on your college campus, then maybe if we are utilizing, or we are hiring a professional agency to do it, some agencies or some companies are having their diagnostic data collected from that solar panel through a sensor. So those sensors are connecting to the solar panel, checking the health of the each panel, checking the absorption ratio, if the panel is drawing power perfectly or not, it is up to a threshold ratio, or some kind of software updation needs to be there if it is management software which is present on it, or some kind of replacement job, or when the maintenance is coming up, what kind of maintenance is to perform. So all these kind of information can be collected from that device, and that information is transformed, or it is transferred through network. So that's why it is collected and exchange data. Now when we talked about data, of course that data can be collected for further usage. So if we talked about healthcare industry, nowadays we are having smart healthcare devices. Like you are having nowadays it is very common to use, you are having oximeter with you to capture your pulse, heart rate, oxygen saturation. So that is what, that is your internet of thing, or that is your sensor based application. Now that oximeter is having both the communication ends. It can be on the network, or it is on a standalone machine. So on the standalone, it can collect these kind of vital information and store into a storage, and then we can connect that device to a machine. We can take that data and we can proceed it into a further application. So what kind of application it is using that data? Application which is working on AI part or neural networking to detecting some kind of diseases. Like you can detect oxygen saturation ratio, and if there is not a proper oxygen saturation is coming through that patient, or it is not that blood is not properly oxygenated, so maybe that person is suffering from hyxemia or some kind of disease. So that kind of control or that kind of prediction can be possible through that data. So that data can come into a various form, that can be in a wavelength, that can be into a graph, that can be into a plotter, that can be into a various stuffs. So the machine which is analyzing that data, so rather calling it as a machine, we can call it as a model. So there are different models we can build, and to train that model we need to have these kind of differentiated data to train on that machine, to machine to understand it. So for that training also, these devices, the internet devices or the IoT devices, are collecting that information and sending it back on the network. So like we just talked about the IoT, that it is a device and application which is connected to a network, or used collaboratively to achieve complex tasks. Now, what is a collaborative efforts here? Collaborative effort means, just we talked about, we are having a oximeter, that is a IoT device, or that is the electronic device which can be connected on a network, and whatever the data is collected from that oximeter, or you can see ECGs, or you can see the modern ICU equipments, or you can say respirator, or your what ventilator or something. So from that, whatever the data is getting collected, that data is stored on the cloud. So the another mainstream technology comes cloud. Then that cloud is processing that data and creating a data set which can be again fed to a machine or to a model to understand it and then predict further things, like in the future, based on these kind of analysis or these kind of data which is collected from all these devices, it can predict that a particular patient may suffer from all these kind of diseases because of the past history of detection or the past history of the hospitalization, and depending upon that, patient can be treated again for preventing that kind of disease or to prevent all these kind of. So this is the very wider scope what we can see over here, right? So that's why it is a collaborative effort. As I said before, only IoT cannot make a life sufficiently smoother. It needs to be integrated. Like if we can again taking an example of smart cities, then that smart irrigation plants or smart sewage system or smart transportation system. Now when we are saying that these are smart, means exactly what they are: collecting that data, processing into a model, and predicting future or predicting the future aspects of what needs to be performed or what needs to be avoided, kind of a situation, right? So that's why it is a collaborative effort to complete the complex task. So you can build a home health monitoring system where you can monitor a particular person's health. So like take a hot example, today what we can see, a COVID patient. So we can create a health monitoring system where we can have different sensors and modules to be used. Like you can use a good amount, a good sensoring capacity of oximeter. You can have a temperature sensor, you can have vibration sensor, you can have heartbeat sensor with you, you can have ECG sensors or ECG models with you, collaborated on a different kinds of controllers or the programmable boards. Now when we say controller and programmable board, now what I mean to say it, you can have Raspberry Pi, Arduino, or you can have your own chipset ready, which can be mounted with all these sensors and modules which can collect that information. Again, you will be having a communication controllers, like you can have Wi-Fi or Bluetooth, WiMAX, RF, these kind of modules which can take your collected data and transmit it on your cloud or transmit on your machine, which can be further analyze that data, or which can collect that data in such a manner which can create a data set and can provide that data set to a model on the machine learning approach what we have created. So on the other hand, when we talk about model of machine learning, there are main three types of learning what machine is going to perform. Like first is now the decision how you are going to train your machine is totally on the developer side. You need to select the one of the approach. Like you can select supervised learning approach, or you can select unsupervised learning approach, or you can select reinforcement learning approach. But my personal favorite is reinforcement learning approach. Why? Though taking a fact that in initial times when you apply reinforcement learning, it provides you very slow results. Why? Because it is gradually understanding the things. Now again we are jumping on our previous example of a baby. Now when that baby is old enough to crawl, and now that baby wanted to go to his or her toy room or to a box where the toys are putted. So that time, if that baby is at a bedside and that baby is crawling towards the door side. Now if you can closely observe that baby, while crawling, baby is seeing everywhere and understanding what is there on that environment, learning all the environmental points, learning all the short points till the vision is allowed. uh, So that baby is trying to accommodate all the things. Means what? That baby is trying to adjust him or herself onto that environment, and then it reaches, or that baby reaches to a final goal, or what we can say a final destination, like that is a toy or the box where the toys are kept, right? So at that time there are various reward systems we can get. Now what is a reward? Reward means when you fulfill something, you'll get something in return, you'll get something as a what we can say prize, or as a satisfaction. At that time baby is getting two kinds of rewards.
Hello, participants. Maybe he's facing the net problem or light issue at his end. Uh, so I'll talk with him and we'll again come back. Yeah, he's in. So just wait for 5 minutes. Yeah, speaker is facing the problem at his end. Light issue is there. So I'll share his PPT and then he'll present on his mobile. So please be wait for 5 minutes.
Hello. Hello.
Yes, sir.
हाँ.
Shall I share your PPT or you are sharing your presentation, sir?
नाही सर, तुम्हाला शेअर करायला लागेल. प्लीज शेअर माय PPT फ्रॉम युअर साइड.
Yeah. Sure,
This
sure, sure,
thing
sure,
has
sure.
been gone.
Yeah, I'll share your PPT. You just present things. Just wait.
Yes, yes.
Please,
Yeah.
please. Yes, sir. Please go ahead. At which slides we are? I
Please,
think
yeah, please be on this slide. Yeah, be on this slide.
this one up.
You can go down.
Okay.
Yeah, keep on IT tech ecosystem.
Yeah. Okay. This is na.
This is the one, IoT ecosystem.
Okay. 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 Please go ahead.
Yeah. So again, very sorry that my here at my place electricity is on a very variable mood today, as there was a very heavy rain at my side. So what we can do, what we were discussing about the machine learning approach. So once we are having these IoT devices ready with us, we can train these devices, or we can train our model in a similar kind of the learning mechanisms. Like we were talking about the reinforcement learning. Once we are again getting on the same example, while that baby is crawling, that baby is seeing at all the round and trying to adjust him or herself into that environment, and then that baby is understanding from each steps. So that baby is taking the rewards. Now that both kinds of reward that baby is getting, one is a negative reward and second is a positive reward. So when we are saying a negative reward, what exactly it means? For example, if that baby is crawling towards door, or where the toy boxes lay down and there are the toys, so at that time, when and on a particular path, if something comes in between, like mummy or papa of our baby is come into it, or maybe another chair or a table comes into that path, so what that baby will do, baby will stop for a moment over it, sees that particular hurdle, thinks something, and then overrides that hurdle, or we can say takes the another route, again moving to the another route, again searching for that particular goal which is there on that baby's mind, and after that again rearranging the path and going towards that path. Now the thing of the reward is not stopping here. After getting on the destination, now that baby, if you observe, after playing with that toy or that location, the babies, 90% babies are having a habit like that. Those babies are coming back to the original position from where they started, right? So they are taking the exact same route to get on that particular start point. At that time, when that baby comes on the hurdle, which is encountered by him or her earlier, at that time the baby is not stopping. What baby is doing, baby is taking the another route, adjusting that route on the same route and going further. Now that is the reward what baby got. That is the negative reward at the first time, where that baby is stuck. Baby analyzes what is there, I can penetrate into it or I can bypass it or not. That baby bypasses it, correcting its path, correcting that baby's him or her path. So that is the negative reward what that baby got. Baby learned something out of it, right? Baby learned that if these non-movable item comes, I need not to waste my energy to move it, rather than I can choose the another path and recollecting all it. That is the learning what baby has. After on the second time, when baby is coming back to the original position, that time baby already learned with that previous experience that this is the non-movable part. Baby corrected that path, him or herself itself. So that time baby got the positive reward. Yes, these are the things I need to avoid, or these are the things I can bypass, or these are the things I can navigate. So these kind of learning, and the beauty of reinforcement learning is we never forget it. When we first time learn how to walk, how to talk, how to eat, how to say something like that, how to write, we are not forgetting it till our lives end. So this means what? Your reinforcement learning, whatever the rewards you will be getting on the reinforcement learning, those are kind of permanent rewards and those are kind of permanent learnings. But in terms of supervised and unsupervised, this is not the case, where we will be having the approaches which are already setted. There your machine is not going to understand by itself. So if you wanted to have a super intelligence, or if you wanted to have a extended human like a thinking in your machine, then always go with the reinforcement learning. So once we are talking about reinforcement learning, so we need to consider various things, what kind of environment we are having. uh, I'll encourage you to see a one Hollywood movie. That movie name is Kill Switch. Now in that Kill Switch, what has happened, we are already fascinated with the robots, right? So if we are seeing the sci-fi movies, science fictions movies, so always we are getting robots or a spaceship or something kind of thing. So in that Kill Switch also, what was the story is that these are the military grade robots which are understanding and analyzing the real soldiers position of fighting, real soldiers position of what we can say, um, fighting the wars, how they are encountering with the enemy, how they are firing, and what positions they are taking when they are getting a counter fire, right? And that all situation which is learned by that machine is again tested over the other machines. Like those learnings are passed on to the other slave machines, and those machines are exactly mimicking the same positions of the real soldiers and fighting with the real soldiers. When the real soldier realizes that these machines are mimicking us, these machines are taking a copy of us, or they are cloning us, and they are learning our new stuff, at that time they change their position. So that is also their learning. So once they are applying their learning on it, they are still into a learning mode where they are learning the new what new positions what those soldiers have taken, or the new changes what is there in that environment or in that scenario, and then they are accommodating that change also, predicting the entire thinking path of those soldiers. So how those soldiers are thinking, what kind of training they were using, or what kind of positions of firing, taking the aim, hitting the targets, on what place those soldiers are hitting on the target. So all things are captured by this machine, and further that they are predicting what kind of next move that soldier can do. And finally they are creating their own war scenario and putting those soldiers in a trap, and they are firing at them with the different path what they can take, and they are already analyzed their paths and their all techniques. So they are already aware about how the next move that soldier will going to take, and they are countering all those moves. So this is the perfect example of the super intelligence what you can get. And you can get the super intelligence through what? Through reinforcement learning. So if you can see in this scenario, in this type of example, in a kill switch, you're having a robot. So what that robot is, what that robotics are doing there, so that robot is the internet of thing machine. That is the thing which is controlled over the network, or which is getting controlled by itself only. So that robot is thinking, analyzing, and predicting the moves with the base technology of what? The electronics, or we can say, or we, for our what we can say, age of understanding, we can say the uh, IoT, we can say. So if you can see over here, we are having a IoT ecosystem. So let's get a move on it. So what exactly IoT ecosystem is? So on the very top level, we are having an application layer. So before the application layer, there is a business layer. Now what business layer is? Now that business layer is defining your strategy, defining your end product, defining your end consumer's requirement, and defining your what kind of things you need to put into your application. So your IoT application or your research methodology or your induction of ML into it, it is totally depending upon what your customer is demanding. If your customer is demanding high definition channels on your normal SDB, then what you can get? You can get internet TV. So that kind of application you can always think, but thinking or keeping in mind the end user's requirement. So at the very top of the IoT ecosystem, there is a business layer. So that business layer defines your action. Then there will be an application layer, which is responsible for creating and deploying your applications. Now, keeping in mind of the user's requirement, you can think about what kind of applications you can build. Then you can have a network layer. That network layer you will be creating, that device you will be creating for your application. So that network will be there. Now when we say a network, it need not to be always a internet. It can be your Bluetooth, it can be your WiMAX, it can be your RF, that is radio frequency, it can be your nano frequencies, it can be your RFIDs, it can be your IR, or it can be your VR. So these kind of networks what we can get, or it can be a wired or a wireless network in a very nutshell we can say. So in a very simplistic manner, if we talked about, it can be your wired or a wireless network, right? So that network layer is handling all your data transfer. Rather saying data, we can say information exchange. So all the information which is being collected or which is being transformed, or even if you are programming your controller, or if you are programming your chip, or you're programming your entire board, Arduino board or Raspberry, that time also you are having a particular network. That time also your board is connected via some kind of application, like it can be connected via USB with the COM port. It means what? It is connected with a serial network where you can put your data onto it. So every type of communication is having its own limitations as well. Serial communicate, if you are connecting your device with a serial bus or with the serial communication port, then you will be having a very minimum bus ratio, or you are having a very minimum stream ratio, or we can say rather than on to again another part will be you will be having a restriction of a data transfer speed and transfer rate and storage as well. So all these kind of hurdles you will be getting. So overcoming that serial communication, what we will be having? Well, we will be having a digital communication where you can connect your device through Wi-Fi, or you can connect it through your WiMAX, or you can connect it through RF, where all these communications channels are getting opened with the higher bandwidth and higher transfer rate, where you can control your device much faster and in a much efficient way. So the network layer is also equally important in terms of controlling your devices. Now when we are talking about controlling your devices, now into IoT, you have already seen many projects which are working on drone. So if we see the penetration of drone projects, if you are taking 10 projects at the same time, only 3 or 4 projects are actually flying. But others are encountering with some kind of problem like ECS, like that is the electronic controller or the signal controller that is fried, or you are having what we can say a main controller or the flight controller. That flight controller is not properly calibrated, or it is not properly configured. The gyroscope which is taking the measurement of a wind speed, now that depending upon that gyroscope is working on the barometer or it is working on the electronic magnet field. So if it is working on the barometer using the G point with the electronic magnet or the magnetization field, then it is affected by wind. So whatever the wind flow is there, according to it, it will be adjusting your vehicle or it will be adjusting your drone. So failure in that, or collaborating that barometer is fail, or gyroscope collaboration, your XY axis needs to be collaborated. So all these things are what? These are not only configurations what needs to be done on that drone, it all are the communication channels from which that drone is getting inputs or taking some kind of learnings out of it. Like that barometer is continuously synced with the height, like it is talking about the height based on the air pressure and winds pressure. It is stabilizing your vehicle or your drone at the various channels, like you can have a loiter mode, or you can have alt mode, that is the altitude hold mode or something, so depending upon that. So that's why the network layer is very important on that. And even with these things, you can have the auxiliaries, like you can have a camera which is taking a photograph and sending it onto your cloud, having a GPS module or GPRS module or a 3G module or 4G light module. So there are IoT SIM cards which are available. There are IoT RF modules which are available, which can fetch all these technologies for you. So these all things are considered into a network layer. So we need to think about, to achieve your final goal, what kind of networks or what kind of modules which can communicate with your device is required. After that, the perception layer. Now what perception layers are, these are the main layer where the sensors are sensing, or some modules are getting your raw information. So if you're having a what we can say, uh, for a very realistic and very simpler manner, if we can take, you are having a soil sensor. So what that soil sensor is doing, soil sensor is measuring humidity pattern, or we can say liquid pattern onto that soil. Even with, if we only talked about soil sensor, there are different types of soil sensors are available. So now I'm touching with the agriculture field, where the IoT and ML can be utilized. You can actually create a autonomous vehicle or the drone system which can test your soil, which can predict the future anomalies which can be happened on that soil. Anomalies means what? Kind of phosphorus ratio or zinc ratio, currently what those things are having, taking that data set, putting into the ML application, detecting the future scope, like in near future of 5 years, what kind of filterization needs to be done on that soil, or what kind of crops needs to be taken. So those kind of predictions you can do with the ML. Even if you're having already field which is growing, you can take the photographs of your crops and can check with the different diseases. So all these kind of auxiliary things you can get. So there you will be utilizing your sensors and your modules for capturing all these kind of raw information, or we can say the preliminary information, which will be fed onto the machine learning approaches, depending upon what kind of learning approach you have given, reinforcement or structure, your supervised or unsupervised, it will be processing your information and it will be presenting that information further, right? So sir, can you please make the next slide? Yeah, so we were talking about the layers, like we are having business layer, application layer, processing layer, then transportation layer and perception layer. Now here on the processing layer, the part comes where your data will be stored. So if you are having a particular autonomous vehicle which is capturing all this data and storing on something, so that kind of layer will be your processing layer, where your information is getting processed, right? So talking about all these kind of sensors and modules, I'm having some sensors and modules with me. I would like to demonstrate those to you. So unfortunately currently I'm not having a power with me, so what I'll be doing is I'll be showing all these modules or the different development boards. Currently I'm having development board with the Arduino family. I'm not having a Raspberry Pi. If you wanted to create cost effective prototypes or cost effective devices, you can use Arduino or cheaper boards where you can find Raspberry. It is also a very good board, and it is having a very good power in terms of computation. If you compare it with the Arduino, definitely whatever the output you will be getting through Raspberry Pi, it is much more fine, or we can say accurate, than the Arduinos, or whatever the operation you will be doing. But again, for all these kind of quality, you need to spend more. So if you are new in this, or you are doing this project first time, or you wanted to develop a cost effective solution which can be benefited to a very what we can say, variety of persons which are having economical differences into it, so you can use Arduinos. because sensors and modules what you can get, those are similar and those will be working similarly on both the development boards. So it can be your Raspberry, or it can be your Arduino. Those all sensors are working in the same manner what that sensor is intended to do. So what I'm having is, currently I'm having different Arduino boards. Like, I wanted to demonstrate them one by one to you. So this is the Uno I'm having. So I'm having the official version of the Uno. It is not the Chinese clone, but it is a second copy, and not made in China. It is made in Italy only, because the original board you will be getting in manufactured in Italy, but it is a second copy which is developed in Italy itself. Why I'm taking the second copy? As far as the cost is concerned, again, if you're moving with the Chinese board or the second copy, these are pretty cheap. You will be getting this for 340 bucks, 340, or max to max. If you are looking at the various components onto it on this chip, you will be getting it for 500 rupees, max to max 500 rupees. But I managed to get it into 310. So this is the Arduino Uno R3, which is having Atomega chipset over here. I'm using a IC controller. I'm not using a board which is having a SMD, because SMD, if we talked about in the maintenance part, it is difficult when if your chip is fried, or you're doing something experiment on it, and if the electric current is passed, high current is passed, or something went wrong with your some kind of sensor or module, then maybe your chip is fried, your main controller, your boot controller is fried. Then it is very easy in IC controllers to replace this IC, but it is difficult to replace SMD components, because you need to have a heat gun, then you need to hit it in a certain manner, then you need to remove that SMD component, SMD chip, then you need to get the new SMD, and resoldering that SMD, sometime it is a very difficult task. So if you are not good at soldering, then no, don't go for the SMD. SMDs are cheaper than ICs. You can get SMD in a difference of 100 rupees. So if I'm going to purchase a SMD, then it can be of 200 rupees only, right? 1 minute. So again, I'm having, that was the Arduino Uno. I'm having this another tiny device, which is Node MCU. Now what Node MCU is it is again a development board, but having your Wi-Fi chip installed, pre-installed on it. So what this board will give you, this board will give you a variety of GPIO pins, that is digital input output pins. So you can reprogram it, and you can use it for a variety of communication and programs. Like, I can put into access point, and I can put into a client mode, both the parts. So this beauty, or the beauty of a Node MCU is, like, if you wanted to control your devices remotely, or if you are having any access kind of application where you wanted to access all these kind of diagnostics data, or you wanted to control your entire gadget or entire device from remotely, you can use Node MCU. Or you can use only ESP chip, like here, which is already shoulder on it, but you can get the Wi-Fi controller, or you can get this Wi-Fi sensor separately. Again, you can use it with your ordinary boards, but Node MCU is really making a good devices in terms of security devices. You can create locking systems with it. You can create RFID sensors with it, or RFID lock systems with it. So talking about RFID, so I'm having one of the RFID, a basic RFID read and writer, which is based on RC 522 board. So here is the RFID scanner, which is a scanner and writer both. can scan your RFID, and it is again compatible to scan your NFC cards as well. So if you are having the Wi-Fi signed enabled card or debit card or a credit card, these fraudsters nowadays are creating hacking or the scamming devices. So these scamming devices can utilize one of these kind of chip, where even this chip is also kind of compatible to read NFC data as well. So I have already tried it with my NFC card, resulting I got a data, but I destroyed my NFC chip because mistakenly I have programmed it to dump all information and destroy my chip data. So that's why my debit card is fried now. So I cannot use NFC again on that debit card, but still I manages to get that data. So if I can create that reading device, so I can create a skimmer on it. So already I have created, so I can create a skimmer. I can put this into my pocket. So what I need, what else I need to have, this chip, the controller, we can say. Then I can have Arduino Nano or Node MCU with me, which is again a very small in the size, which can be easily fitted into your pocket. And I need to give power through battery, so I can have 9 volt or similar kind of a battery power to it, and I can create a skimmer device. So whenever I move into a crowd and somebody is having, or many of us are having NFC card, which is NFC chip is already enabled, then it can capture all that data. Data means what? Unfortunately light is not here, so that's why I cannot demonstrate you. But what kind of data you can get through it? You can get card number, CVV number, expiry date, and your card identification number. So all these four details you can get through NFC, and you can utilize again it for cloning another card, or these fraudsters are using it to clone another card or sell that information. But I'll advise you not to do it, as it is legally it is not preferred, because it is a cyber crime or scheming, or you will be directly get behind the bars if you got caught. So for research, you can see that in NFC, near field communication, which is a extra fine layer of RFID only. So how the radio frequency identification is working the similar way, but on the more secured part, NFC is working. But still you can break that security. Even you are not breaking that security, you are just dumping that information through it. But again, nowadays, whatever the NFCs you are getting onto debit card or credit card, those are having a good security layers, or those are having updated security algorithms on it. So this device cannot clone it, but there are other NFC sensors which can do it. But still, for a go, you can create a project, like you can create a project for fraud detection, where you can utilize this sensor to detect a particular NFC's information, and you can create a fraud account, or you can clone it, and you can have a NFC algorithm which is tuned for a better security and encryption, and you can reprogram that NFC card, though your debit or credit card having non-programmable NFC chips as of now. So I don't know. Further, when I research on it, I'll find out the way how to rewrite them, as I'm doing the re-engineering as well. So onto it, if you're getting a NFC card which is a rewritable chip inside it, so you can rewrite that particular information which is having a better security algorithms on it, and you can always have a better solution on it. So that project you can do, or it can contribute in your fraud detection programs. Even you can create a access point mode through Node MCU, through this Node MCU. So what you can do is you can create a fraud detection on various phishings. Phishing is the method to harvest your information online. So you can create there are various router phishing methods are nowadays in popular in terms of security, because fraudsters are not going to crack your Wi-Fi. What they are doing is they are creating a mock page, or they are creating a rogue access point where you are forced to connect with it. And once you are connected to that rogue access point,
on the your browser part, you will be showing a notice like your browser needs to be updated or your firmware needs to be updated. Provide your Wi-Fi key to access internet. And if that user is not well aware about these fraudster techniques, that user is putting their Wi-Fi password onto it, and after that even you can modify that page to have your admin account user ID password as well. So once that user is putting all that information is collected on the receiver's end. That receiver end is also hosted on the same node MCU. So you can create this node MCU as a hosting access point, or you can host your application on it, like the application what I just talked about. And you can collect the various information, and you can hack into that Wi-Fi and can make the changes onto it. So those kind of hacks are already there. But in the better part, if you can think, you can take your node MCU and can host your collection application. Like you can collect the various information what you need from your sensors, and you can collect it and you can store it onto a node MCU. Even there are some ESP node MCUs which are available, which are having built-in camera onto it. So you can create a camera security device through it, or you can create a application platform where you will be deploying your application onto your network, and you can give actually the internet to it. So internet facing application also you can put into. Even with that, I'm having another device. Let me show you. Just a moment. Let's take it. So here it is the another Arduino board, which is a Arduino Mega, which is slightly bigger than the Arduino Uno R3. So this is the SMD Arduino Mega. So you can see over here the big chip which is installed. That is the SMD at Mega chipset, and you will be getting a lot more IO ports onto it, and you will be getting a better receptions through Mega. So if you're having a variety of sensors to be utilized in a single go, like for example, if you are using a home automation, then on that, if you wanted to create a home automation system with the machine learning onto it, now once somebody is going to enter that, your camera will identify that is a person or not, means that particular object is a human object or a non-human object. Once it is detected as a human object, that time only it will switch your device will switch on your lights or whatever the appliance you wanted to. Otherwise it will not. So that kind of if algorithm, if you build on it, that kind of home automation system you build on it, then you can save your energy a lot more time than the previous one, and you can have a successful ML application installed on it. So to do it, you need to have camera modules, you need to have if you are using RFIDs for motion detection, or you can have PRI modules, you can have a laser module. So there are different modules. Even the electronical relays you need to use to switch on, and mechanical relays or electrical relays you need to use. So all these can be fitted properly on the Mega rather than on the Uno. So it is again only the concern is Mega is having a good processing capacity, and it is having IOs more than R3, Uno R3. Even if you wanted to apply it on a very small scale, like you wanted to create a variable device, so you can always utilize Node MCU, or you can utilize this one. This is the Arduino Nano you can have. Even it is a SMD chip. Here you can see Arduino Nano SMD. So you can see that now if the SMD is fried, then it is very difficult for maintenance purpose. Even if you wanted to do it on much smaller scale, then you can again utilize the Arduino's Mini Pro. So again, this is the smallest version of the Arduino chipset. Even nowadays, there is a Nano Pro as well, so where it is having a good capacity of processing. So these kind of small reprogrammable chips can be utilized into application like healthcare, or you can utilize it into what we can say your sports, where you need to have various devices to be created in a very short time, or their applications are on the body, or some applications are there. One of the applications of IoT onto healthcare is, nowadays the researchers are creating electronical pacemaker, which is fitted onto a heart, which is again their entire functionality can be controlled via your mobile app. So how they are going to connect a pacemaker which is fitted into a heart, or the besides the heart, and connecting to a mobile, I'm not quite sure about it, whether they are going to use Bluetooth, or they are going to use infrared or IR, and how safe it is with the heart, or the magnetic inferences side. I'm not quite sure about that, but still it is what it is into research. So they researchers will be coming up with that. Uh, Even if we talked about the healthcare application, you can create your own ECG monitoring application and can connect it with cloud. You can utilize Autodesk Cloud, or you can utilize, there are multiple solutions for cloud deployment, or you can have a simulation ready, or you can directly connect your devices with Amazon Cloud or Azure Cloud, which are most secure clouds in terms of security and your information, because healthcare data, which is very sensitive data. So what you can do is to create your own healthcare device, or monitoring device, or ECG device. You can have this kind of chipset. I'm having it. So this is the ECG sensor or module, where you will be having ECG buds as well. Let me tell you that. Let me take it out. It is difficult to work with one hand only. So this is this one. So this is what this is the ECG capturer, or we can say a module, where you can plug your ECG buds through this jack. Even this is a reprogrammable, so it can be operate low on Arduino Nano, and it can be compatible with any other development board. So all these sensors are multi supported, means what, these sensors can be utilized in various board. Even you can use it onto Node MCU, you can use it Arduino, you can use it on the Raspberry, you can use it on Intel boards, you can use it on Samsung board, any of the chipset, or you can create your own chipset and you can utilize. So, and what it will do is it will continuously monitor your heart rate or ECG kind of data, and can collect that data, and you can pass that data on to your very similar very in a simplest manner. You can collect that PCAF file, captured file, and you can import that data in your SolidWorks, or you can import it into MATLAB for different application. Like you can apply regression on it, you can apply supervised learning on it, or you can apply different ML application on it, and you can specify whether that particular patient is having some kind of diseases or not, what will be the heart functionality ratio, or the BP or something. You can predict all these things on it, not only with the this data. Even there are sensors which you can put onto your throat, or in not onto in the throat, and they can test with the swab. So you can have COVID predictions. So you can test swab through that. Even but testing swab with the kits which are available on the market, with the COVID kits, that is more advanced technology which is going on. But there are research which is going on, and there are sensors already available which can be inhaled, or there is a nanotechnology sensors which are already been developed, which is in the form of capsule, and that capsule you need to take, and that capsule will be delivered through your blood vessels to a particular location, and that capsule sits there and continues to tracking the location. Even if somebody is having heart disease, or somebody is having stomach infection or something, so that capsule will go at that particular location. How it will flow through your blood vessels, and through that it will reaches to it, and then it start reading out the particular ratios, like what is the acidic content in your stomach, it is usual or it is keratin level is going to high. So if keratin level is high in your blood, then maybe a kidney functionality may affect on it, or some kind of these areas which that capsule can take. So that capsule is enabled with machine learning algorithm, where that capsule is capturing that data, and when you remove that capsule, uh, really I don't know how you will be removing it. So there are different techniques, like you can extract it from your veins from taking the injection kind of blood or kind of thing, and you can read that all data which is being collected by that capsule, or that capsule is transmitting that data out of your body, like you are seeing into a wi-fi sorry, not wi-fi, sci-fi movies, those capsules which are injected into a heroes or villains arm or the tooth or something, they called it as a bug, and that bug is continuously tracking that person, so that information is being transferred already. So similarly, these health capsules are transmitting this valuable input towards the health application, where that application is running with the machine learning algorithm and taking on to that inputs, it is processing it and detecting or predicting what kind of situation that person may get into, or kind of disease that person may get onto, right? So these are the various things which are available. I'm having pretty of the devices with me, but time is not that in our hand, so I cannot demonstrate it uh, uh, very well right now as well, because the power issue at my place. I'm very sorry for that. I'm really apology. I'm asking your apology for it. So I think this is for the day. If you're having any doubt, any questions, you can put into a chat, because it is very difficult to have a session like this on mobile, because I'm not really able to demonstrate everything. But still, if participants are having any doubt, any questions, please ask.
Yeah, sir.
Yes.
Yeah, ma'am. If you have questions, you please ask.
Yeah.
Otherwise, I'll
Thank
ask. No. Yeah,
you. Okay,
please.
Nish. Thank you so much, sir, for such a wonderful session. And we are grateful for the time and the efforts you have taken to share your thoughts and experience. A few questions we have from the participant. With your permission, I would like to take them.
Yeah, sure, no problem.
Yeah. So, one participant, Bimal Bhatt, is asking what is the difference between IoT three-layer and five-layer architecture?
IoT.
Three-layer and five-layer architecture.
Okay, the ecosystem what I have shown you, that is regarding with it, that there is no that such a great difference, but the only thing is what the technology or what the layers are being added. What I'll do is I'm having a pretty good documentation regarding it, so I'll mail it to the organizer, and I request organizer to please share with the participant, so there all the differences and what are the applications of each layer is properly demonstrated. So it is better to read it out, and if you're having any further questions on it, I'm giving my contact details, you can reach me anytime on it.
Okay. So there is another question. Thank you, sir. There is another question for Narigalkar Akshay, that IoT for healthcare application.
Mm-hmm.
So you have already explained few applications, but, that a
Yes,
participant
that
is.
I wanted to share one application as well. If you remember, some years ago, Intel have introduced their a chip, or we can say a variable device, kind of a helmet, what you can wear it on your head, and it is analyzing your neuron frequencies, and through those neuron frequencies, it is predicting the move. And even some time ago, they have created ad for it. Chess players are using that gadget, playing chess without touching that mm, what we talked, called it as a chessboard and all the players on it. So without touching on it, they are doing it. So how they are doing it? They are only thinking about the move, and that move is already being played by a computer. So it is a kind of a further, or we can say a IoT health kind of a application which is already being in progress. So there are already professional mind thinkers, we can say, kind of a device is available. You can purchase it. It is a spark plug, spark fun, not spark plug, sorry, spark fun is having one of it. So you can purchase it, you can wear it on your head, and you can think only the command. You can create an application, like you can think only the command, automatically that device will interpret it through your frequencies which is going on, because through the when you are thinking, some kind of electric pulse is getting generated, and your heads are having a lot of other vents as well, they are getting affected on it. Like the oximeter is calculating your oxygen saturation ratio onto it. So it is calculating what you have think, and it is converting into the action and providing that action to your application. If it is a robotic arm and you wanted to move it from left to right, and that arm will automatically move left to right without pronunciating your command, just to by thinking of it. So you can utilize this kind of technology which is being developed through IoT in healthcare for what we can say, for doctor can think about operation, and that operation will be operated on a particular patient through robot. So that kind of application we can think about, and that kind of applications can be made in a research term. It is not created such, I just thought about it, so you can work on it also.
Okay, thank you so much, sir. Vimal Bhatt is have also having one more question. That is, what is the role of a fog computing with IoT?
It is again a subjective one, that fog computing is very good alternative to your the traditional computing environment, as you will be getting a lot of good resources to compute. Because if you are uh, as the IoT is a collaborative channel, so if you are collaborating machine learning for computing onto it, so it can have a better network ability in terms of communication, in terms of processing, in terms of having the CPU utilization and all. So you will be having a good architecture, or we can say a platform or the infrastructure to build your heavy duty applications, or to build your where the applications is having a lot of amount of data to be processed. Because the devices or the modules or sensors what we can get, these can generate the data, and they're having a very limited amount of resources to process it. So we always require these processing powers to be harvested by these different kinds of environment, or we can say we can put it into a cloud environment, we can put it into a virtualization state, or we can take the fog computing for connecting grids to it. So you can have a multi-grid grid architecture for supporting this. So I think if you are moving on to the SCADA system, then this kind of fog system will work with the SCADA system, and the deployed IoT devices or the BOT devices at the field, or maybe on the electrical ground, or maybe on to assembly line, to collect various information on it. Even you can use fog computing and IoT to have a effective utilization over a nuclear plants, where the nuclear plants are responsible of creating electricity, or harvesting the neutrons and doing some research on it. So there also you can utilize it, because there the computation is much required than the memory. So there you can utilize it. So that is just my thought. You can thought on it, you can utilize in that way as well.
Oh, thank you so much, sir. There is one more question from Soumi Banerjee. She wanted to ask, what is the security algorithms are there in these cards? Whatever cards you have shown. So in these cards, what security algorithms are there?
Security algorithms, it is based on the application of the device what we have. It can have a PDA, or it can have machine to machine communication algorithm, and based on that you can have TLS, what we generally called it. It is a transmission level of security. So what kind of data you are collecting, it is totally depending upon how you are sending it. So if you are using, like Honda have already created an application where you are syncing your mobile phone with the Honda's CPU. So the TLS algorithm, transmission level security, or the SSL certificate, or the cryptographical solutions, PKIs or something, or RSA certifications are applied on the transmission of the data, keeping in mind that whatever the data is going to transfer or transmitted from the car or getting collected on that device is secured. So no other hacker, we can say that, can interfere into it, change that data, or make some changes onto it. So that way they are securing it. And I believe that a variety of tasks like the collection of the data, processing it, it is already being done on the car CPU level only. So what that device what that application is doing through Bluetooth or through Wi-Fi or through infrared, so whatever the application is doing, but into a blink you can utilize blink software for doing it. Or Honda have created their own software, so on that they have given two options, like you can connect car through Bluetooth, or you can connect car through Wi-Fi using their infotainment system. So the heart of communication with that car is infotainment system. So that infotainment system is having plenty of security algorithms, like cryptographic algorithms mainly, and transmission level security algorithms already installed, which is taking care of all the security part on the car itself. And only the data which is encrypted is sent over the channel, and then it is received on a mobile application, and again it is decrypted in a very simpler manner. We can see it is decrypted, and then you can see it. Like you are using WhatsApp. WhatsApp is also having end-to-end encryption. Now what WhatsApp is doing, WhatsApp is not storing any kind of information on their server. What they are doing is the information is already there available on the recipient side and on the sender side. So you can observe that. So if anybody, one of you has deleted your photograph, so after viewing that photograph some days, it is showing you the error that photograph is no longer available on the channel. Why? Because it is deleted from the recipient side. So it will be automatically marking a key on our side also that particular communication is lost now. So keeping that in mind, so the application of end-to-end encryption is totally different in various terms, but you can have it in a very simpler manner.
Okay, thank you, sir. There is one last question that I wanted to ask. From that question is from Professor B. Sahu. He wanted to ask that it is necessary to communicate between IoT devices and controller through any server or dedicated cloud is must.
No, it is not that compulsory. As I have already shown you the ecosystem of IoT, at the very apex level, there is a business layer which is sits on. So, as per your requirement of transmitting your information, and as per your requirement of collecting various information, it is totally depend on that, that how exactly you wanted to create your infrastructure. You can put it into a cloud for your ease of use, or you can create your own environment at yourself. Like I told you, you can create the hosting platform through node MCU as well, so that node MCU is collecting data, hosting on itself only, and you are utilizing it, but it will give you a very limited range of operation. So if you wanted to utilize it further more with the further vast application as such which is in your mind, then you can go with the cloud. Cloud is preferred in terms of when you are having collection data and you are creating a data set out of it, or you are having a diagnostics data to be processed. Like in example, we just talked about the solar panel. So that diagnostic data is collected on the cloud, and you need to manage your users. Like I'm having 1 lakh users where I have deployed my solar panels. So I need to utilize which user having which problem. So at that time, cloud is recommended, or we can not only cloud, a normal data center is also recommended. You need to have a web application to control that data, but it is again subjective depending upon your use, depending upon your infrastructure which is in place, and depending upon what sensors and what kind of data you wanted to harvest or you wanted to collect.
Okay,
It is not
thank you.
as such compulsory.
Okay, thank you so much, sir, for such a wonderful session. This much questions we have received from the participant. Uh, Thank you so much, sir, for such a wonderful session. Over to you, Vaibhav, sir.
Thank you, ma'am. Thank you. Thank you, sir.
Thank you, sir. Thank you, sir. Thank you very much. It's a really nice session, sir. Actually, maybe participants observe the so many things. Even I observe also. While during the presentations, our speaker was seated with every devices related to IoT as well as presentations. But still, a light issue is faced at their by his end. But still, he is presented all the things, show the demo of some devices, and that is how it's shows that the commitment toward the words, dedication towards our fields, and that is why even yesterday also he said that sir, light issue is there, could you shift these sessions to the another day, so that we organize these sessions in the today's morning. Thank you, sir, thank you much. It's a really very nice session. I read a few comments, online comments, for the different participants. For your information, sir. Dr. Raja Mohammed saying the nice way of putting things together. Again, even one or two persons, Dr. N.K. Sakitwal, is asking your number, sir. If you could give permissions, I'll give the share your numbers to him. Then,
sure, sir. Share my number, WhatsApp number, and my email ID to all the participants. So in future, if they are having any concerns or if they want any training as such, they can definitely contact to me.
Yeah. Dr. Subhashri, she is also asking, dear sir, please provide your contact number. I'll share with every participants in the comment box.
Sure, sir.
Yeah. Excellent demo and information, sir. Soumya Banerjee's. Then N.K. Saketwal, superb, good presentation, useful session. So many comments were good. Anita Patil is saying that very depth and informative sessions. Even though we have led the sessions for the 10 to 12 minutes, but right now it's at 12:26. So we cover the timings. That also. Thank you, sir. Really thankful to you. So here we ends our today's sessions. Thanks all of you, sir. Yeah.
Thank you, sir. Thank you, participants, for listening me very patiently and having a very patient time when I'm reconnecting to the session as because of the light issue at my end. Thank you very much. Definitely, when we'll have another opportunity to interact with you, then I'll make sure myself that I can show you a much more demo and in a very good position to demonstrate it. So thank you very much for giving me opportunity, Vaibhav, sir, and thank you,
Thank you,
ma'am,
sir. Thank you.
for
Thank you,
interacting
sir.
all the participants and with me. Thank you. Thank you. Thank you very much.
Thank you.